Key features of exponential functions. So here's a huge list of all the different key features we talked about. And for exponential functions, we're just going to add one little thing to these key features, and that is the term, the very last one, called an asymptote. So the definition of an asymptote is a line that the graph continually approaches but never touches. And all exponential functions have this. They all have an asymptote. It's always going to like approach a particular line, but it's never going to touch it. So all these exponential functions are going to have it. And more specifically, for exponential functions that we're using this form for, it's always going to be the x-axis, or in other words, y equals 0. But I'll get to that more when we reach that on number 1. Okay, so let's determine the key features here. So domain, we've done a lot. We got arrow on the left. We got arrow on the right. It's going to continue to go forever in the x direction on the left and continue to go forever on the x direction on the right. So it is all real numbers. It's going to go all the way to negative infinity and all the way to positive infinity. The domain is all real numbers. Now the range, though, is not. I know it's kind of hard to tell from looking at it, but this line is never going to go below this x-axis. It flattens out at it. It doesn't even touch the x-axis, actually, which we'll talk a little bit about later. But it's never going to go below the x-axis. The range is never going to be, the y value is never going to be negative. It's only going to be positive. It's never going to be negative. So the range, y, will be greater than 0. It's never going to go below 0. Increasing interval. So remember, when we read these, we read it left to right. When we're talking about increasing and decreasing, we're saying as x increases, what happens? So if we look at this graph, it's never increasing. When we read it left to right, it's decreasing the entire time. It's just going down. It never loops back up. It's never going up, never loops back up. This is decreasing the entire time. So for the increasing interval, I'm going to say there's none. But for the decreasing interval, it's the entire time. So you could say just all real numbers it's increasing, or sorry, decreasing. It's decreasing the entire time. You could say all real numbers, but I'm going to write it in a little bit different notation because it kind of wants an interval. So I'm going to say from negative infinity all the way to positive infinity, this is increasing. It's decreasing. Geez, my bad. It's decreasing the entire time from negative infinity all the way to positive infinity. Literally the entire time, this thing's decreasing. Speaking of that, positive interval, remember when it's above the y-axis, sorry, the x-axis. It's positive when it's above the x-axis, and it's always above the x-axis. So that is the entire time as well. So from negative infinity to positive infinity. It's always positive. It's always above the x-axis. And it's never negative. It's never below the x-axis. So for the negative interval, there is none. Now the end behavior is a little bit interesting. So as x goes to positive infinity, as it goes to the right, where's the y going? Well, if you look at the line, it's going down, 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 and it just kind of hovers over 0, and it's getting closer and closer to 0, right? As we go in the x direction, it's getting closer and closer. I'm just tracing it over and over again. It's getting closer and closer to 0. I just want you to see that. So as x goes to positive infinity, y approaches 0. It doesn't go down in negative infinity. It doesn't go up to positive infinity. It literally just like approaches the y value of 0. So then we're going to say it approaches 0. Meanwhile, as x goes to negative infinity, as we go this way, I'm kind of tracing it over and over again, it's going up to positive infinity. The asymptote is that line that the graph continually approaches but never touches And kind of like it said in the notes up there, it's going to be the x-axis. I'll draw it in blue or something. Now let me draw it in green. It's this line. It looks like it touches it, but it's actually just getting smaller and closer and closer and closer. The asymptote for this line would be the x-axis. In other words, y equals 0. Okay, so I know these ones are kind of weird, the key features for exponential functions, but just take your time with it. So I'm going to skip B and C for you to try, but number 2, I'm going to do number 2B and then also 3, which are similar to the graphs. I just need graph it first. So maybe follow me along on 2B and 3 before going back and doing the rest. Okay. So this, let's just graph it here. -3, -160 would be here. -2, -80 here. -1, -40 here. 0, -20 here. 1, -10 here. And then 2, -5 here. Then here. Okay, so try to connect these. Okay. And the table actually kind of helps with some of this stuff too, because we can refer back to the table as well. Okay, so the domain, again, it's going to continue to go on forever in the negative direction, and it's going to continue to go on forever in the positive direction. So we're going to say all real numbers for this. Now the y is a little bit interesting here because the range, it's the whole graph is below 0. So in the y direction, so y needs to be less than 0. The increasing interval, remember we read it left to right, it's actually increasing the entire time. It's going up, albeit it's going very slowly up when we get to this 3 and 4 and stuff. It's going to go up very slowly. So it's increasing the entire time. So you could say all real numbers, but I'm going to write it in a sort of interval from -infinity to +infinity. It's increasing. It's never decreasing when we read it left to right. It's never decreasing. So the decreasing interval, I'm going to say, is none. This graph is also never positive. It's below the x-axis the entire time. So positive interval, there isn't any. There's none there too. But it's always negative. It's always below the x-axis, right? So that's from -infinity to +infinity. In terms of its end behavior, as x goes to +infinity, as we go to the right, it looks like it's approaching 0 again. Right? Let me just star what I'm looking at here. Over here, it looks like it's approaching 0 again. It's the line as x goes to +infinity, the graph gets closer and closer to 0. And you can see that with the table too. If it keeps on dividing by 2, it's just going to get closer and closer to 0. So this is approaching 0. But as x goes to -infinity, it's going to keep on going down here, right? It's going to keep going to -infinity. The g of x will go down to -infinity. Asymptote, same thing as the last thing. Look, it's never going to touch this x-axis. So again, the equation for the line of the x-axis is y equals 0. So hopefully that clicked a little bit more than the first one. Show you another one. Okay. Let me do number 3. Same thing, except I just need to fill out the table. Okay. And I'm going to do this pretty much all in the calculator. Okay. I'm not going to write it all out. So I have y equals 5 times 2 to the power of x. So I need to plug in -3 first. I'm going to plug in -3. So 2 to the power of -3. Remember, there's that yx button you can use for the negative exponents. So 2 to the power of 3 negative. I got 0.125. Then times 5. And I got 0.625. Okay, let me do -2 now. 2 to the power of -2 is 0.25 times 5, 1.25. Let's do -1. 2 to the power of -1 is 0.5 times 5 is 2.5. 2 to the power of 0 is 1. 5 times 1 is 5. 2 to the first power is just 2. 5 times 2 is 10. 2 to the power of 2 is 4. 5 times 4 is 20. And you can kind of see the pattern in the table right now. It's multiplying by 2 each time, which makes sense because that's the, the B value. So this should be 40 and this should be 80. So let's graph it. -3 is at a very small decimal of 0.625. So there, 0's at 5, could go there. Then I got 110, 220, and then 340, and then 480. Okay. Try to do this nicely. Okay. All right. So that's the graph. So let's determine the key features. Domain, again, it's going to go forever in the negative direction, forever in the positive direction in terms of x. So x could be all real numbers. The range, it's never going to go below the x-axis. Never. It's only above the line y equals 0, right? It's only above. So y needs to be greater than 0 for the range. The graph is increasing the entire time. Remember, we read it left to right. It's increasing the entire time. So I'm going to say from -infinity to +infinity, this thing's increasing. It's never decreasing. So none. Positive interval, it's always above the x-axis. So I'm going to say it's positive from -infinity to +infinity. It's always positive. And it's never below the x-axis. So there's no negative interval. No. Now, as x goes to +infinity, that's off to the right. We're talking about end behavior now. It's off to the right. It goes up. It's going up to +infinity this way. As x goes to -infinity this way, it looks like it's approaching 0. It's going down. It's not going to go to -infinity. It's never going to drop below that x-axis, but it is approaching 0. It's going to 0. And lastly, the asymptote, again, it's the x-axis. It's at y equals 0. So I know these key features for exponential functions are a little funky. I think they're a little more confusing than any of the other functions, but that's the idea behind it, okay? So you go back and you try to finish the rest of the stuff.